Chapter 10 is all about sequences. A sequence is an ordered list of objects. And these objects are typically numbers, although they don't have to be numbers. In this first example, 2, 4, 6, 8, this sequence has 4 elements. So let's look at some notation. An A with a subscript 1 represents the first term. An A with a subscript 2 represents the second term. And an A with a subscript n represents the nth term. In this particular sequence, A sub 1 is 2. A sub 2 is 4. And A sub 5, well, we're not given A sub 5. There is no A sub 5. This is a finite sequence. Let's take a look at another example. This is an example of an infinite sequence. This goes on forever. In this case, A sub 1 is 7. A sub 2 is 5. In other words, the first term of the sequence is 7, and the second term is 2. The fourth term in the sequence, to find out the fourth term, we'll need to look at the rule. Well, this is being subtracted by 2 for each successive term. So the fourth term, we just subtract 2 from 3, and so the fourth term is 1. A recursive sequence is a sequence in which the terms are given, one or more of the terms are given, and then subsequent terms are defined by using one or more previous terms. This is an example of the Fibonacci sequence. The first term in this case is 0. The second term in this case is 1. And to get the next term, we're going to write out this formula. A sub n is equal to A sub n minus 1 plus A sub n minus 2. Now, what does this mean? Well, if we want to find the fourth term in the sequence, well, that is going to be A sub 4. In other words, n is equal to 4. Okay, so let's look at this formula. So A sub n, in this case n is 4, is equal to A sub n minus 1. So in other words, we're taking the third term and adding to it A sub n minus 2. Well, if n is 4, 4 minus 2 is 2, so we're going to add A sub 2. So in other words, to find the fourth term in the sequence, we're going to add together the third and second term. So the third and second term are 2 and 3. And so that is, 1 and 2. Which is 3. Okay? Let's take a look at another example. In this example, this sequence is defined recursively. The first term is given, so our sequence A sub 1 is 4. Now, if I want to find A sub 2, in other words, the second term in the sequence, I need to take the previous term, that's n minus 1, multiply by 5 and add 2. So that's 5 times A sub, well, if n is 2, and n minus 1 is 1 plus 2. Well, since A sub 1 was given, this is 5 times 4 plus 2. And so the second term in the sequence is 22. Now, if I wanted to find the third term in the sequence, that's going to be 5 times the second term, because this is n minus 1 means the term before. The previous term is 22, and we'll add 2. And so the third term in the sequence is 112. The disadvantage to a recursive sequence is that to find each term in the sequence, you have to know the term before. Let's take a look at this one. Now, this is a sequence where the individual terms are not numbers. They are polynomials. So the first term is given to us. Now, to find the next term in the sequence, that is the previous term plus 3x plus 4. To find the nth term, it's the n minus 1 term, which is the term before. Okay, so let's find the second term in the sequence. Well, the second term is the first term, or the previous term rather, which is 2x minus 1 plus 3x plus 4. So the second term in the sequence, we can just combine the like terms. It's right there. And to find the third term in the sequence, that's the term before, so the second term, which is 5x plus 3 plus 3x plus 4. And so we simply combine the like terms. So the third term in the sequence is 8x plus 7. And you can do that for each term. Now let's look at an explicit sequence. So an explicit sequence is a sequence where each term is defined by its position. In other words, it is a function of n. So, for example, a sub n equals 3n plus 1. Well, what's the first term in this sequence? Well, to find the first term, a sub 1, we'll let n equal 1. So a sub 1 is equal to 3 times 1 plus 1, which is 4. The second term in the sequence is 3 times 2 plus 1, which is 7. The advantage of an explicit sequence is you can find any arbitrary term in a sequence without knowing the ones before. For example, we can find the 10th term in the sequence without knowing the 7th, 8th, or 9th term by letting n equal 10. So 3 times 10 plus 1. So the 10th term is equal to 31. Let's take a look at this one here. The first term in the sequence is 1 squared minus 4, which is negative 3. If I wanted to find the 22nd term in this sequence, that's just 22 squared minus 4. So 480. So that's a basic introduction to sequences, recursive sequences, and explicit sequences.